Hello, everyone. I'm not very familiar with this format or the tool I'm using, so if anything goes wrong, I'll take all the blame. But we're going to go through a bit of OpenStack and some of the ecosystem and some of the tools. There should be some time for questions and answers. I'm more used to looking out over and seeing people's eyes, so it's kind of strange sitting here in a room talking to myself without hearing you guys. But I am watching the group chat, and then when you guys put questions with the queue, then I should see those more explicitly, and we'll just kind of take it as it comes. I just want to reiterate something that Yasmina said, which is that there's probably more expertise in the audience than there is in the speaker if you add it all up. So I'm sure you guys have things to add. Talk amongst yourselves, add comments to the chat. I think that will add to the medium. And then I also might take certain things for granted that you know certain things, or if I'm using jargon, I don't want to move forward if there's something that's really confusing. So if you can pop things in the Q&A that I could explain, in a minute, I don't want to rabbit hole too bad, then that will help clear up some things. So that's kind of where I want to go with this. As interactive as possible. It's the internet, right? That's the whole point of this. So just to, I don't really want to waste too much time introducing myself. There's probably a little bit of lag when I was testing this earlier, so I might not have exactly the flow that you guys are seeing. But I'm on LinkedIn, I'm on Twitter, whatever. You guys can read about me. You read my bio, so I did some stuff, blah, blah, blah. That's not why we're here today. And I also would just like to preface this with, if you've ever seen me talk before, it's a bit of a ride, and hopefully it's a fun one. Keep your arms and legs inside at all times. And like I said, it's going to be fun. So I'm not going to waste too much time with definitions of what is cloud computing. I think if you're in this chat, you probably are past the point that you believe that there is something going on. I don't think it's useful to spend time dealing with definitions and taxonomies and standards and all that stuff. I basically want to be able to solve problems, and hopefully we can get to the point where you have not necessarily all the answers, but better questions. And just to kind of put this in perspective, what I think we're going to accomplish today, I'm basically going to, in 1 hour, save you a few hours worth of reading so that you have about 100 hours worth of reading to do to be able to do some of this. Reading and tinkering and hacking. So what is OpenStack? Let's talk about this. In the beginning, there was an idea, and I'm going to kind of leave the first part of that story off, the rise of Amazon Web Services or how we got to the point where we're at today. But Rackspace and NASA released a project called OpenStack roughly 15 months ago, June last year. The OSCON, there were some things that obviously went on behind the scenes before that, but that was sort of the public coming out party for OpenStack. And it turns out that Rackspace had already sort of gone through a first generation of their cloud and come to the conclusion that they wanted to do something different than they were doing. And NASA was trying to solve similar problems. And what I think, if you're really following the arc of this story, and you look at what that first release of OpenStack was, it wasn't so much that you were getting a cloud framework that was released and ready to be put into production. What I feel it was a kind of a social contract that the development of this cloud framework, this cloud infrastructure was going to be done in the open. And to that, I think you have to applaud the way that, I mean, I won't necessarily say that there hasn't been some interesting twists and turns to that, but for the most part, Rackspace and NASA have gone out of their way to do what they can to develop in the open. So if you're really following the plot of this story, there's also been kind of a rolling involvement of other companies. And these companies that are on the slide that hopefully the lag is not so bad, you can see now, are basically companies that have in the last year demonstrated through some involvement in the community, with the code, with what have you, and also with certain sort of business-focused activities, are trying to add value and possibly capture value from the growing OpenStack community. But that's only a fraction of the story. So there are, I mean, this slide doesn't necessarily do it justice. When I made these slides last night, I probably left some people off here that I should have on here. I know, Midakura is probably a good one. There's another group that's done a lot, especially if you're doing sort of, most people, it seems, have focused on Ubuntu, but CentOS has been sort of championed by Mirantis. They've done a great job. And then the rest of these people on here are doing, they're either trying to build a service on OpenStack right now, or they are committing, Puppet and Opscode have recipes that they've released. There's a bunch of other recipes or manifests that have been released by those communities. Dell has, we'll talk about this a little bit later too, but they have a tool called Crowbar that's pretty cool. Citrix has committed to an OpenStack distribution. NTT Data did some of the IPv6, cloud scaling, and Stratus, RightScale, Nebula. All these people are sort of coming together and working on this open project to build the next, whatever. Who knows where this is going to be, but we'll talk a little bit about the momentum of where we're at and how we got here. So these are just numbers I took from the OpenStack website. There's 110 companies. If you go to the website, click on it, you can see a bunch of logos, and I feel like everything in the universe sort of has this power law distribution where you have, a fat head and then a long tail. And if you look at those 110 companies, the fat head is, towards one end is Rackspace and Dell and Citrix and, Piston Cloud Scaling, Nebula, and then goes down to people that, do all sorts of things. And that's another, I don't want to get too sidetracked by some of the politics, but there's basically, on one end, there's a bunch of people writing code, trying to make something happen, and then the long tail is a lot of press releases. So we'll just keep going from there. But there's service providers who are, I know personally there's over $50 million that's been put into companies that are trying to monetize some sort of OpenStack-based product. There's a bunch of interest from hardware vendors for obvious reasons. There's a bunch of service providers who are trying to kind of take their offering to the kind of the next level, and they realize that it's probably easier for them to leverage this community than to try to do this all by themselves. At the end of the day, that creates a very interesting landscape. And I'll give bonus points for whoever can put into the group chat what this picture's from. But you basically are seeing a proliferation of ideas about how to do some of this stuff. That's reflected in the code so that you get a lot of ideas about how these things should function and interact. And we'll go through a little bit more about what OpenStack actually is and what it does. And then, yes, Jeff Hobbs is correct. It is the Grand Bazaar in Turkey. It's if you've ever been there, or ever get a chance to go there, check it out. But you basically are going to get clouds of all shapes and sizes. And OpenStack is a framework that is attempting to provide you as a user, you as a sysadmin, ways to address the needs. And that could be something on one end of the scale where you need to manage, or you have 10 compute nodes and you're going to manage maybe 100 virtual machines to people who are trying, they're spending literally millions of dollars, tens of millions of dollars, hundreds of millions of dollars trying to provide services that are, web scale, or whatever that word means to you. So I want to walk through the projects. If you go to the website, OpenStack.org, it lists these three as the main projects. I'm assuming there's a little bit of vocabulary here. The infrastructure, the service, compute is the EC2. EC2 define this space. It's basically the easiest definition for me is I can make a web service call and I get back some indication that somewhere is a virtual machine with my name on it, and then I can go and make it do whatever I want because I have the power. Object storage is essentially S3 or rack-based cloud files, which lets you store whatever arbitrary data in over HTTP and then request it back over HTTP. So it's basically a way for you to put images somewhere, or that could be images, that could be text, that could be whatever, and then get them back. And then Glance sort of grew out of the need to solve this problem that you have a bunch of things you kind of need to keep track of, which is, RAM disks and machine images, and Glance lets you hook up Swift. It also will support other backends and then feed that into Nova. And then it's also worth noting, especially with the newer release, that there's these other services that have kind of been promoted, and I think they're actually going to become more and more important, which is Keystone providing a unified authentication service, and then the Dashboard project, which we'll see a little bit later, which provides you, kind of the front-end GUI experience without some of the. It's kind of, if you've used EC2, it's kind of like the website EC2 has that lets you look at images, and it has a system kind of administrative side, and then it has a user dashboard lets you look at images. Now this is a call to arms because these projects clearly need logos. If you go to Apache and you look at all the projects, most of them have really interesting and amazing logos, and OpenStack has one logo that's kind of this umbrella, and I think it'd be really cool if there's a nice logo for each of these projects a year from now or 3 months from now or whatever. So that's a call to the community. So let's get some logos, all you artists. So this is not strictly true, but this is kind of a way to, there's a bunch of sort of sequence diagrams and interactions, but this is kind of a high-level architecture that gives you the story. So you have the internet, you have a bunch of people on the internet, and then you have these running services, and technically there's probably some cases where the users would touch Keystone too, but the unified authentication is provided by Keystone. Your dashboard is, like I said before, it's a UI. Nova is marshaling the resources required to provide virtual machines. Glance is loading the images, the machine images that are required to do that from Swift. That's kind of the high-level story. And then Swift itself has a lot of other use cases for serving whatever random files or static websites or whatever you could use a HTTP-based key value store for, you can use Swift for. So I went and I did a little bit of research to kind of give you guys an indication of the momentum of these projects. And this is Nova. I don't know if you're familiar with the website Olo, but if you're into open source, then it's kind of an interesting website. They do a bunch of metrics on open source projects. So Nova, in the last 30 days, had 281,000 lines added, and 121,000 lines removed from 42 committers. And if you go look back to if you look at the slope of that from the last release to now, Nova has basically doubled in size, lines of code, and to a first approximation since the Cactus release. And I think that's very telling of what we talked about earlier, which is all the energy and resources being thrown into this project. And next, sorry for the dead air, Swift is basically a little more mature. It's based off the Rackspace cloud files, and it's not seeing as active development, but part of that is because it's much more mature. It's been running in production, and there's not as much being changed because it basically works. Then you have Glance. They didn't have an OLO, but just looking at it, and this is looking at the GitHub and the Git, but it's about half the size of Swift, more or less, and about twice as active right now. Dashboard is a smaller thing, but it's pretty active. It's going to be, I think that you're going to see a lot of interesting features come into the dashboard just because there's a lot of focus on it. And then Keystone, this authentication service, is about half the size of Swift, but about twice as active. So that's kind of the overview of the momentum of this project. And that leads us to something that just happened, which is kind of a big deal. The Diablo release, which, like I said a minute ago, looks like, to a first approximation, roughly twice the code that was available for the Cactus release. And the convention that they decide to follow is they're going to go in order of the alphabet, I believe. So the next one will be Essex, and then I don't know when we get to Z what we'll do, but that's Diablo. It's pretty exciting. If you go to the website, I don't want to go through and read the laundry list because all this stuff's pretty visible. If you look at the blog, there's a bunch of announcements about what's in those releases. But it's nice to see the momentum. And I just want to make a real quick comment here. If you've ever used Linux, a modern version of Linux, it's pretty easy. You can probably give your grandmother an Ubuntu CD and a laptop from wherever, anything made within the last 3 to 5 years, and she could have Ubuntu running on a laptop without too much help from you, hopefully. My grandma probably could. And that's a great story, but if you look at what it was like to use Linux, say 1995, then that story was very different. Before you have the rise of the distributions and the proliferation of the package management and the modern ideas that we kind of take for granted, if you wanted to run Linux, you basically had to be an expert in hardware, you had to know C, you had to be willing to have the thing blow up and then rebuild it and kind of go through that. And I think we're sort of in that transitional phase where you have an opportunity to use OpenStack, but at the same time, OpenStack is not going to solve all these other hard problems for you. Eventually, I think that they will be solved through that same sort of mechanism of distributions, and you're seeing some of that happen right now. I don't know. I expect to see more and more of these, but earlier this week there was the announcement from Piston that they're doing a distribution. We already saw Project Olympus from Citrix, and I think you're going to see a proliferation of those types of kind of vendor-supported distributions that have made some of those choices for you, collapsed some of the complexity, and allowed you to deal with that kind of happy path installation they're going to give you. But then again, just like Linux now, if you want things to be working a certain way, you're kind of left up to do that on your own. Also, honestly, each one of these services that we just kind of walked through is probably by itself worthy of at least an hour, and frankly, some of them you could probably spend a good week in a class all day and learn and never stop learning. There's just a lot of depth to what is required to actually deploy and make some of these decisions and weigh this complexity, the combinatorics. If you look at what's supported in Nova right now, and you try to, I mean, this is actually impacting the project when you think about the functional testing and the continuous integration. There's a Jenkins site, but to actually test the combinatoric matrix of all those features and how they interact with each other is not a solved problem. So I'm going to wager that most people are actually most interested in Nova. Clearly that, if you're going to run it a certain way, then that's going to start to get into Glance and Swift as well. But it seems when most people talk about clouds, they're mostly interested in infrastructure as service. If I, maybe John out there somewhere, Chuck, they're more interested in Swift, and I probably know more about Swift than I do Nova, if I'm telling the truth. But I think most of you guys are interested in infrastructure as service. So this is, I asked Jesse Andrews, who's the head of Rackspace Cloud Builders, last night what his favorite architecture diagram for Nova was, and he pointed me to this slide. And this is actually Ken Pepple's slide from the O'Reilly book, then modified for another presentation that Mr. Lindsay did that has all the, it's a distributed architecture. So if you kind of look at the image and map that back to the other, simplified version, this is, with the exception of the grayed out or the grayer parts, the Nova architecture. So Nova by itself has a bunch of moving parts. So you have the dashboard, which is, I guess, technically a separate project now, so then maybe that could be grayed out too. Then you have the Nova API, which is providing an endpoint, and that's actually the kind of public-facing service that everyone's going to go through. And then everything, if you look at the queue right here, in this picture, the canonical installation is using RabbitMQ, but there's been some work done that in the future there's the possibility to implement some other types of queues with some abstraction, so maybe some sort of ZeroMQ or other implementation. And then if you look at the rest of these, you're basically passing messages asynchronously back and forth with the queue and these services, and these services are responsible for coordinating with the abstractions of the different resources, and it's pretty easy to figure out what each one does based on its name. So Nova Compute is essentially keeping track of and marshaling the compute resources. Nova Network is probably, I think you're going to see a lot of active development in the models and the complexity of Nova Network, but it's essentially responsible for keeping the state and the resources for how the VMs are interacting with the network. And then the volume is, like you'd imagine, and you can kind of see from the slide, allowing you to attach to, the way that the documents describe it, it's like a USB stick. It's sort of a EBS equivalent, although that's a hard problem, and there's a bunch of hard problems in how you're going to do storage. We'll kind of talk about that at a high level later. And then Nova Schedule, I think there's also some interesting operational research problems that could be solved in Nova Scheduler. It's basically taking and keeping track of how all these images and disks and network resources are being allocated and trying to optimize them. So there's kind of a simple way to do that, and then there's more complex ways. There's a random approach, but if you really think about how this kind of plays out at scale and with a lot of different possible configurations for disks and RAM, then the bin packing problem or the operational research problem of how you're going to optimize that infrastructure, if you can get, if you're randomly putting stuff in and you have 15-20% waste, and you can get that another 10% out of that, then that might be worth quite a bit to you if you're running this at high scale. So it'll be interesting to see how that part evolves as well. So if you're a developer and you want to get involved, I think that the fastest way to onboard is this DevStack project that the Rackspace Cloud Builders put together. And it's essentially a opinionated shell script that will install every project from source, start all of the services in a screen session. Who's familiar with Screen? If you're not using Screen or Tmux, then you should start now because it will change your life. But it will run all the different services in a screen session, and then you can see, basically the impact of making your changes. Right now, it's basically running the Diablo release. I think this will evolve. I know Jesse and those guys have good plans for it, and they're actually using this as their preferred way to kind of bring up their own development stack. And I think if we as a community of developers get to the point where there's kind of a canonical way to develop, and you can onboard developers with sort of a standard way to get those services up and running, then it will accelerate the code even more. And so I think that's a pretty cool project. If you go to devstack.org and kind of look at the documents, or you can clone it on GitHub, then you can walk through that shell script and you can see how it clones, or how it's basically going to clone a bunch of repos and then configure them. And the default is to run it in a single VM. And then the way that you can configure it, it's a little bit arcane right now, but I'm sure Jesse would be happy to tell you more about it. It'll actually support, through manipulating some of the environment variables, a multi-node deployment if you want to develop against a multi-node as well. And then moving on, so that's kind of a way to get to develop it. Now you can run that on a single bare metal machine, or you can run that on a VM. I was actually playing with it yesterday using Vagrant, which is another tool. Vagrantup.org is a great resource. I'll dump that in the chat. Vagrant, do it. And Vagrant is the way I think of Vagrant. This is sort of an aside, but Vagrant is a tool that lets you kind of think about VMs like you'd think about a make file or making a project. So you can do Vagrant up and get a virtual machine that is clean and in the state of whatever the base box that you're using, and then it can tie into Puppet or Chef or Shell provisioners and do a bunch of magic, and then when you test whatever you want to test, you can bring it down. So if you're developing these kind of configuration management or these kind of deployment scenarios, Vagrant is your friend. Sometimes it's a little frustrating because it moves super fast. That could probably be said about some of the OpenStack stuff. So whenever the virtual box changes or the gems change, then you're going to look at some Ruby stack traces for a minute. But if you're cognizant and you're actually understanding what you want to accomplish, Vagrant will be your friend, and you won't look back after you've used it a few times. So you really want to build a cloud. What does that mean? I mean, the promise of cloud is that you don't actually have to deal with servers, but that's kind of a lie. And the truth is that in the last year of trying to build cloud infrastructure and working on putting together some of these deployments, I learned more about servers and network gear and disks and the drivers for JBOD enclosures and all this kind of stuff than I ever wanted to know about. So it's kind of the dirty little secret that at the bottom of this, there has to be some metal, and there has to be a bunch of stuff, and it has to be powered, and it has to be cooled. And it's one thing, like I said before, on one end, you want to bring up Nova in a VM and run it and see how it works and see the dashboard, and that's kind of cool. On the other hand, if you get to the point where you actually want to run this at scale as a service, it's a hard problem. And I remember that I saw the Eucalyptus announcement at Velocity in 2008, And kind of the dream that was being told then is you have a bunch of this hardware laying around, and you're just going to add it to your cloud, and it's going to work. And it turns out that I think that that's probably a recipe for a lot of pain. And if you're actually going to go and build a service or build anything with any real complexity or scale, then you should think long and hard about how you can minimize variation across all the different parts of the servers and the disk. If you put that together and it's a heterogeneous environment, then you're going to look like this guy. And if you're coming from a place that runs their gear like this, then you're probably going to have a problem too. So people are looking for the cloud secret. I can see Gary Griswold is looking for the cloud secret. But there's no secret. There's a bunch of super hard storage and networking problems, and there's a bunch of compromises that you're going to make. So if you're going to build open source clouds and you're not going to think about each of these sort of trade-offs, then they're going to be made accidentally. At the bottom, while Nova Network is giving you an abstraction that lets you manage some of these resources, the choice of how you configure the actual gear and how that's set up and how that interacts with the Nova software is going to, the complexity and the problems that you're going to work through in doing that. Right now, like I said before, it's kind of like the Linux early days. You have a bunch of ideas, you have a bunch of things, but it's sort of like you're going to be troubleshooting the drivers to get that stuff to work. And then storage, if you've ever used Amazon and you've depended on EBS and then come to regret it, then you probably understand, at least, I mean, if you think about the organization that Amazon has built and how they got to the point where they're at, and the fact that they can't solve that problem in a performant and reliable way, should tell you that it's hard. So if you don't want to listen to this, that's fine. I'm trying to save you some pain later. Now, there's a bunch of other nice tools kind of in this ecosystem. If you're going to actually build a cloud that you're going to run at scale, then the story is there's commodity hardware and it's built for failure. Well, that means that you're actually, at some scale, expecting servers and disk and these kind of things to fail every day. So how do you add capacity or how do you replace capacity? So one of the problems that you need to solve is a bare metal provisioning problem, which is PXE booting. It's the basics of it are fairly well understood. In practice, I think that there's still a lot of interesting problems that could be solved better. And you're basically going to have images, TFTP, DHCP, things boot, magic happens. This is a really cool project that's sort of part of that ecosystem. Dell that I was telling you about, it's XCAT is actually a great tool from the chat. I think there's some things that could probably, XCAT tries to do a lot of things just like Crowbar tries to do a lot of things. I don't necessarily like every choice Crowbar's made, but it's giving you some very interesting functionality where you can PXE boot, and then it's also got a chef server as part of that Crowbar, and then you can associate through some interesting logic and these things called bar clamps. You can associate and actually inspect. So you can inspect the hardware that's available and then make decisions about what should be running there. So if you have something that's got a bunch of disks on it, you're probably going to want to run Swift on that. If you have something that's CPU and RAM heavy, then it lets you, through the profiles, the bar clamps, choose what chef recipes get installed. And Crowbar by itself is a very interesting project. It also tries to do some monitoring stuff, but you could spend another easily a week talking about the configuration and the configuration management tools. And my background coming from the Puppet side, and then also being involved, I've probably written more chef code in the last year than I have Puppet code, but I'm pretty familiar with both of these tools and how they use them. And if you're a sysops person, even if you're just kind of interested in cloud, then that's one thing. But if you actually have servers that you need to maintain and configure, I highly recommend that you check out these types of tools. There's some other ones that are interesting also, but this kind of seems to be the leaders in especially the OpenStack community, and both of these companies have devoted resources to providing sort of the manifest and the recipes to make this stuff. Palette is an awesome tool as well. This basically gives you the abstraction to configure machines based on the things that a sysadmin would already think about. So you have things like mount points and interfaces and packages and users, and you compose those in classes of services. So you have things like your database service or your Nova network service or whatever, and you can go see, if you go on GitHub right now and search for OpenStack, you're going to find manifests for Puppet, cookbooks for Puppet. There's cookbooks from the cloud builders for Puppet. There's OpsCode has a bunch of OpenStack cookbooks. It's sort of a kind of another layer to this community that lets you deploy and manage those systems. And like literally, you could do a week of training on just this topic. And not only do you need to configure, if you're actually going to build services for your company or for some other goal, then the configuration of the actual bare metal resources you have to solve, and that's going to be all those other services we sort of saw before. You have the networking and the rest of the stuff for Nova plus Glance plus Swift, what have you. But you also have a bunch of VMs now, so you're ostensibly going from say 10, maybe hundreds of bare metal to 10 times that number of virtual machines, and those also need to be configured. So this type of this tool will change your life. Even if you don't adopt one of these tools, there's a bit of a learning curve. Just the mindset of thinking about idempotent resources and how you can apply them and what you need to do will change the way you manage systems, I guarantee it. And then I'm going to keep using this slide until people actually get it, because no one seems to. But you basically have these things that you need to provide to have a reliable service. And this is Joe Armstrong. He wrote a programming language called Erlang, and some of these ideas are built into that virtual machine. Right now, if you're running OpenStack, I feel like you basically need to kind of bring your own on some of these other things. So if you're trying to build a service at scale or even that you want to run reliably, then there's a lot of this stuff around the edges that you need to solve. The monitoring, there's going to be more and more. I just saw some work Venos did. Some of the community stuff will probably start to grow in that area. But for now, if you're trying to, and I speak from experience having tried to run this stuff, you're going to need to solve these problems. And it's not going to be something that you get for free, at least not yet. Which brings me to this next slide, which is right now, I didn't want to do any complicated build-ins with this tool, but you basically have sort of this kernel in the center, which is OpenStack, and it's brokering compute network and storage, which is, if you think about how a kernel works, it's essentially the same kind of model. You have compute network and storage resources that are exposed to you through the abstractions of the kernel. But then all this other stuff that you're going to need. So right now, if you want to build an OpenStack-based service, you're going to need monitoring and management. You're going to need to solve these deploy problems. And it's not just the deployment. So there was an article and a discussion about Krishnan from Cloud Avenue was talking about how the deployment of OpenStack is easy, and that's only seeing like the static picture in my opinion. And if you really look at what is going on in cloud and why the advantages that Amazon has are allowing them to do some of the things they're doing in this market, it's really not about some of the features, it's about the operations. And operations, there's an article in, we'll reference O'Reilly Radar, which is operations is the secret sauce to startups. And I really believe that's true. And if it wasn't true, if these weren't hard problems, then I think you'd already see some of these OpenStack-based services. I know there's a bunch of people working on this. Like we talked before, there's a bunch of resources they're being put into this problem, but at the end of the day, I can't go right now, put in a credit card, and launch a VM on an OpenStack-based service. You know, there's been a lot of movement, and I'm excited, and I know some people are working very hard to make that happen, but it's still something that will be in the future, and it's not the reality today. So all the rest of this stuff we're starting to see come on. Billing, if you're going to actually charge and build a service, even if you're going to just do simple chargebacks inside of your company, you have to do non-trivial work to integrate the billing, and that's also not a solved problem. And that might be a good idea for a startup. I don't know. So let's see if we can do a demo. So this, I'm going to show the OpenStack dashboard, and I'm going to try to. This is a cluster that is donated from the Rackspace cloud builders. Thank them. And I'm going to share the screen, and then I'll just kind of show you some of the. This is the dashboard. If you go and run the DevStack script right now, then you'll have running this dashboard on whatever VM or machine, and you can kind of play with it from there too. I'm not going to say there won't be issues because right now it's running the head, but let's try this and see how it goes. So if I log in, then I will have an overview. Right now there says there's no instances on this page. This would show me all the running instances. This has a list of the images that are currently available. So there's a Natty instance, which we'll use in a minute. There's also built-in functionality to take snapshots. And then if you're familiar with the way this whole game works on Amazon, you can set up key pairs. Floating IPs is a way we'll look at this in a minute. I don't have any floating IPs, which is different than I thought. Hold on. Sorry, if it gets clumsy. I'd like we're going to have probably another 15 minutes for questions. So if you guys can start throwing questions into there. I saw a question earlier about the hardware required, and if someone in the audience would like to answer that question, that'd be one thing. But from my perspective, that's an open question. It depends on what you're trying to accomplish. What are your requirements? What are you actually trying to do? If you have a bunch of services that you're trying to consolidate, then that's one thing. If you're trying to build a service that's web scale, then that's another. You can run it on one VM. All right, so let's go to the user dashboard and start one. Sorry for the dead air. So this is an instance that's running right now. I'm going to go to the images. I'm going to launch an Ubuntu image. I'm going to get a little user data. Hold on. Don't ask all those questions at once. This is why live demos are such a great idea. All right, user data. So that will just change the password so you can log on to it without having the key set up. And then we'll do that, and we'll make it a small and then we will launch it. It's launching. Success. We have a VM. Now the way that this configuration works, I should have a floating IP. I'm not sure why I don't. So I will call tech support. Hold on. Okay. Question. Puppet versus Chef. I'll ask. I have hopefully some help from the Rackspace guys. I thought I would have a public IP, and what I want to try to do is launch a VM that I did already, and then I can VNC into that, get a console, and I was going to install Apache and then give you guys the IP address to show that it works. So hopefully we could do that in the next 10 minutes. In the meantime, I'm going to answer these questions. So we have Puppet versus Chef, strengths versus weaknesses of each. That is an interesting question. I've tried to answer that. I kind of got, I won't say baited, but there's a Quora discussion on this topic where I wrote a good 2-3 pages on this. But the main thing I would say is the worldview, where you have Puppet has a very strict notion of what the model is. It also wants to, it doesn't necessarily force you, but it strongly encourages you to have a much more kind of centralized notion, where Chef is a bit more, allows for a bit more procedural thought. And that is, this is going to sound basically philosophical, and I think that's where it breaks down. But you kind of have the dichotomy between what does it mean to do and what does it mean to be. So what Puppet wants you to do is specify things declaratively, what their end state is, and then Puppet as a framework tries to make that all happen, although there are things which, because of the nature of configuration and the way these machines work, you're kind of forced to color outside the lines and deal with some procedural issues anyway. And Chef has some of the same ideas about idempotency, but doesn't necessarily give you that sort of, it doesn't force you as strongly to make things declarative. So that may or may not make sense to you. If you're steeped in the mythology of configuration management, it did, but if it didn't, then I suggest read the Quora post or send me an email, and I'd be happy to discuss it more. So let's see. Who does OpenStack? So right now there is both an EC2 API and an OpenStack API. And there is a bit of a lag, and it's an interesting kind of thread to follow in the community development process, how those APIs are evolving. And I think there's another interesting aspect there because you don't know what's tested or not in terms of the IP and what they can protect. All right, so I'm going to try allocate IP. I was told to just try it. Okay, so I'm going to allocate this IP to my instance. We're going to keep doing this, and I'll keep trying to answer questions too. So I'm associating my IP. So now I have a successfully associated IP. I'll go back to this instance, talk you through that, and then we will start this thing while I answer the next question. So someone tossed out Palette. It's another option. Palette is an awesome project along the same kind of spirit as Puppet and Chef. Slightly different philosophically, but it's written in Lisp or Clojure, where both Puppet and Chef are written in Ruby. So if you're coming from a background where you prefer JVM languages or you prefer Lisp, then Palette is an awesome option. It's a little bit smaller community and a little less rich functionally, but it's an awesome project. Okay, so Darren Daggs asked, can you detail some of the network issues you're alluding to? What is planned to improve the network capabilities of OpenStack Nova? So if you go read the documentation, there's actually several different networking models that are supported, And there's also a, I don't know what the right word is, but there is a community of people, some of them vendors, some of them operators who are exploring different kind of network as a service abstractions. And I think you're going to see some of the most active development in the networking in the next year. So I don't know exactly, I mean, that's probably another hour-long discussion to go through some of these issues, but right now you basically are going to choose different formats for the different types of management of IPs, and you have a flat DHCP and ways to set up VLANs, and each of those kind of creates different trade-offs and features. And then you ask a typical use case for Swift and Glance. So Glance, the reason you would use Glance, the use case for Glance is to provide images for, I'm going to keep trying to type while I do this, for the Nova. And then Swift is the backing store to put those images. So we're talking about machine images. And then you could also use Swift. I know one of the projects I've worked on, they have a Swift installation. It's a pretty big cluster, about a petabyte of storage, and they're using it as a origination server for a CDN, as well as, so they don't actually use Glance or any of or Nova right now, but they use Swift to origination server for the CDN, and then they serve content directly from Swift. So it's basically a way for you to associate whatever undifferentiated bits with some sort of key, and then you request. It's a simple key value store, which is in essence RAM is a simple key value store. It's pretty simple idea. You have some symbol, and then you have some data, and you put the data in with the symbol, and you get it back out. So you can just think of it as this big distributed hash. Let's do this. So I'm going to do apt-get update because that's what all good sysadmins do. And then let's see, keep reading. QA. All right. You mentioned a number of updates were being performed against Nova. Could you highlight the area where these updates are being made? What areas need the most work? If you were here earlier when I was showing the stats for the project, I would say that it's grown. It's basically doubled in size in the last 6 months, and then the majority, if you count the lines created and the lines deleted, large chunks of Nova have actually been evolved and rewritten. And I would say that the areas that need the most work, I mean, if you really want to get involved with the project, there's a list of issues on Launchpad, and there's a list of all these things. But if you really understand networks, if you really understand storage, if you really like programming in Python, there's almost an unlimited amount of work for you to do right now. And if you want a job, you send me an email, I bet I could find something for you to do. So I don't know if there's an area that needs the most work. If Jesse or some of the cloud builders are in the chat and want to dump an answer to that there, then I'm sure you have a better perspective than I do. All right, now I'm going to install Apache. And I'm sorry for the crappy JavaScript DNC artifacts. Apache is installing. Who does okay, that we already answered the APIs. Has anyone written a GUI front end for managing Swift, i.e. adding and removing accounts and containers, and for that matter, any front ends to the Swift files? I know some that have been written that are not open right now because of some of the projects I worked on. There's the dashboard that I am demoing, actually has Swift integration as well. That's not installed or turned on the one that I have here, but there is that, and actually the Swift APIs, they're not that complicated. And if you're familiar with the API, you could probably have a dashboard that does some of that stuff written in Rails or Django or something in I mean, for first pass, you could probably have it in a couple days, afternoon. All right. Is there an appliance ecosystem around OpenStack today? So I could launch an instance that has a network device such as a firewall or a load balancer. Yes-ish and no-ish. I would defer to. I know there's some stuff kind of in the works for that, and there's been some work on. If you go to the page for the project, one of the sub projects that's not kind of an elevated first level project is called Atlas, which is a load balancer as a service. That's trying to do integrations to manage some of the load balancing stuff. I think that's, in addition to the networking work, how we're going to do load balancing and try to do some of the kind of ELB type stuff is interesting. All right, let's see. So we should have a. I think that should work. Let's close this. So you guys should. So I just launched the VM, put it on a public interface, installed Apache, and then you should be able to see with the IP address I just dumped in the chat room that the Apache was successfully installed. All right. Question, can it provision storage devices? If yes, how many types of storage devices does it support? I think the right answer there is probably no in terms of the devices, but the way that the Nova volumes or what you need to do to set up the actual storage, you would expose something like iSCSI or whatever the other. There's a couple options if you go look at the way that works. So I would say that in terms of provisioning storage devices, the answer is probably no. In terms of the protocols and the types of storage devices support, it's a few, and then it could be implemented. That's one place I think you'll see a lot of active development as well. All right. Is there any identified bottlenecks within OpenStack at the moment? The queue system seems a possible candidate, for instance. Do you have any real-world data of deployed OpenStack instances? So, Gildas, the queue obviously could be a bottleneck at the scale that I've seen, which is hundreds to low thousands of nodes. That queue is not really a problem, at least not yet. And then there's also the possibility to abstract the queue service and do things with maybe 0MQ or something else. If that brokered approach becomes a bottleneck, I think that another way to do that is at the level where you're having the queue, which is essentially your control backplane, and if your control plane is congested, then you probably did something wrong. Then you can split things into zones. So if you think about the way Amazon's presenting their infrastructure right now with the different availability zones and regions, then there's probably some practical limit to the way they've implemented things scaling, and that helps them to decide the size of those zones. And I think you're going to see that same sort of thing. Right now I don't have really good data about the top end of that, and of course it's going to depend a lot on your use case. So the way that you use the infrastructure is going to have a big impact on the way that those underlying services hit that queue. And Darren Daggs asked, do you feel OpenStack is better served on top of KVM or Xen? That's a loaded question, like the Puppet Chef one. I think that of the available options for hypervisors, that those are the two that make the most sense. So if you read the list of support, there's a bunch of other hypervisors that are theoretically supported, but realistically, I think it comes down to a choice between KVM or Xen, and it's a debated topic as well. But I think that kind of looking at some of the things that are going on, KVM seems to be a little more forward-looking, and Xen seems to be a little bit more mature. for whatever value mature and whatever that word means to you. So that's kind of how I would, try to politically correctly give you that answer. Yeah, it's probably worth mentioning, thanks Jess, that there's active IRC channels. All these things are being discussed every day. There's also a mailing list, and I see Ann Gentle's in here answering questions here. She's in charge of the documentation for the project, and I'm sure she would, as much as there's an opportunity to get involved and help write code, there is a ton of documentation. It seems like in open source projects, documentation always lags implementation. So I'm sure she would take any volunteer effort to help write documentation. And it's getting better and better all the time. So that seems like a lull. Are there any more questions or anyone questions, comments, or war stories? Yeah, it absolutely needs improvement, but you should have seen the first release. Yeah, exactly. That's I mean, having been part of different open source communities and struggled with this as part of personally part of the Puppet community, it's you always want to do the code, you always want to make that better, and then for some reason, I don't know why, developers don't just love writing documentation. It's crazy. I think that's probably the end of the webcast. We got to the end of our hour. I hope you enjoyed it. I hope you learned something. Like I said at the outset, I'm not sure I'm going to do much more than save you a couple of hours of reading so that you could do another 100 or so. And thank you for your time, and I hope you enjoyed it.